So this is expression for delta H is equal to delta U plus delta nRT. Here delta N is equal to summation of number of moles of gaseous product minus summation of number of moles of gaseous reactants. So this should be gaseous reactant. So this is about relationship between delta H and delta U for chemical reaction. Then next point is work done in chemical reaction. So work done by a system at constant temperature and pressure is given by W is equal to minus P external delta V. W is minus P into bracket V2 minus V1. Therefore, W is minus P V2 minus P V1, as P1 V1 is equal to N1 RT and P2 is equal to N2 RT. Therefore, this W is equal to minus N2 RT minus N1 RT. So this becomes W is equal to minus delta N RT. Here we will consider, so question can be asked, derive the equation for work done for chemical reaction. The next point is sign conventions. Here if delta N is positive, that is N2 is greater than N1, then work done is less than 0, that is negative. And if W is negative, that is work is expressed in negative, then work done is by the system on the surrounding. And if delta N is negative, that is N2 is less than N1, then W is greater than 0. It indicates that work is done on the system by the surrounding. So you have to remember these sign conventions. Next point is enthalpies of physical transformations. In this case, we will consider first enthalpy of phase transition. In it, first is enthalpy of fusion. So definition is enthalpy change, that is heat enthalpy change that occurs when 1 mole of a solid is converted into liquid without change in temperature at constant pressure is enthalpy of fusion. So definition of this is enthalpy of fusion is enthalpy change that occurs when 1 mole of solid is converted into 1 mole of liquid without changing temperature at constant pressure is enthalpy of fusion. This is endothermic. For example, H2O solid is converted into H2O liquid. This is enthalpy of fusion. So delta H is equal to plus 6.01 kilojoule per mole. Reverse of this reaction is enthalpy of vaporization. So enthalpy of vaporization for this is H2O liquid is converted, enthalpy of fusion, and this enthalpy of fusion is conversion of liquid water into the solid, and delta H is minus 6.01 kilojoule per mole. That means enthalpy of fusion and enthalpy of freezing is opposite. Its magnitude is same with opposite sign. The next point is enthalpy of vaporization. Enthalpy of vaporization is enthalpy change accompanying the vaporization of 1 mole of liquid without changing its temperature at constant pressure. So its statement is enthalpy of vaporization is the enthalpy change accompanying the vaporization of 1 mole of liquid without changing its temperature at constant pressure. Consider example, H2O liquid is converted into H2O gas, that is vaporization takes place, and delta H vaporization is plus 40 kilojoule per mole at 100 degrees Celsius. If reaction is carried out at 25 degrees Celsius, then enthalpy of vaporization is delta is H2O liquid gives H2O gases. It is equal to delta H is plus 45 kilojoule at 25 degrees Celsius. Means if temperature is changes, we can get different values of enthalpy of vaporization. Reverse of this reaction is enthalpy of condensation. So when H2O gas is converted into H2O liquid, this delta H is minus 40.7 kilojoule at 100 degree Celsius. So this is about enthalpy of vaporization. Then enthalpy of sublimation. Enthalpy of sublimation. What is sublimation? The conversion of solid into gas without transforming into the liquid. So it is the enthalpy change for conversion of 1 mole of solid to 1 mole of gases, 1 mole of solid into gas directly at constant temperature and pressure. So if this H2O solid is converted into H2O liquid, then delta H sublimation is 51.08 kilojoule at 0 degree Celsius. This is addition of two reactions, that is H2O solid is converted into H2O liquid. This is enthalpy of fusion, and this enthalpy of fusion is 6.01 kilojoule per mole. If this H2O liquid is converted into H2O gas, this is enthalpy of vaporization, and this enthalpy of vaporization is plus 45.07 kilojoule per mole, and addition of these two is enthalpy of sublimation.